The AIRMET is a concise forecast designed for low-level aviation using abbreviated plain language. It is applicable for aircraft normally operating to flight level 100, but in some mountainous regions this is extended to flight level 150. The format of AIRMETs does vary from country to country, but many common elements are found in them all. In the UK, AIRMETs are produced for 8 different geographical areas. The information contained within these AIRMETs is entirely consistent with the information contained in the 215, which is valid for the same time period. The regional AIRMETs for areas of Scotland, North England and Northern Ireland, and South England and Wales are produced 4 times a day. The sub-regional AIRMETs for areas Central, South East and South West are produced 3 times a day, whilst the cross-channel AIRMET is produced just twice a day. We will now take a look at a typical UK AIRMET and go through it section by section. You will soon see that it looks very familiar, because a lot of the abbreviated plain text uses the same abbreviations which we saw in the lessons on low-level significant weather charts and the SIGMET. The example which we will now look at is from a Southern Region AIRMET. The first line of our AIRMET is a description of when the forecast is valid. In our example, the product is valid from 1100 to 1900 UTC on the 18th of the month. The next section of text is a short description of the meteorological situation which will affect the area of the forecast. Comment is usually made of any fronts which will affect the region, together with any movement. Details of air mass changes will also be given. Common, concise, plain English is used to describe the meteorological or MET situation as it is usually called. Below the MET situation is a line or two of text which details any strong wind warnings which are expected. These are added whenever the wind is expected to exceed 20 knots. This threshold applies to gusts as well as mean speeds. Just below the strong wind warning is the more general wind forecast for the AIRMET region. Forecast winds are given at flight levels 060, 030 and 010. At the end of each wind forecast is a forecast of the temperature which can be expected at that flight level. Any changes in wind and/or temperature are indicated by way of abbreviated text. In this example, the wind at 1,000 feet is expected to be 20 knots, from direction 330 degrees true, gradually becoming 30 knots, from direction 280. The temperature is forecast to be plus 5 degrees Celsius. Immediately below the section of text which describes the winds is a forecast of the freezing level. Sometimes this varies spatially across the AIRMET region, and sometimes with time. For example, when a cold front moves through the region. Any changes are highlighted by way of concise descriptive text. The main section of text, which appears immediately below the freezing level, is a description of the weather conditions forecast for the AIRMET region. This region is often broken up into distinct zones, with different weather assigned to each zone area. In our example, we have 2 zones. The boundaries of these zones are highlighted by way of explanatory text. If these boundaries change with time, then movement is described accordingly. The boundary of Zone 1 in our example is given at 1500 Zulu and is a line northwest from Morecambe Bay to Waterford and is moving southeast at a speed of 40 knots. Within each zone is a description of the different weather elements which are forecast to occur. These weather elements include forecasts of visibility, weather, and cloud. The latter includes cloud bases and tops, and the quantity of cloud. These different weather elements are written in the same order as they appear on the UK Low-Level Significant Weather Chart, the 215. The same abbreviated plain language is used, which you should be becoming familiar with. We will now run through the lines of text contained in Zone 1, so that the structure of the information becomes familiar. We start with general conditions of 25 kilometres visibility in occasional rain. This is accompanied with 6 to 8 octaves of cumulus and altocumulus cloud, with a base of 2,000 feet and a top of 14,000 feet. Occasionally, the visibility will reduce to 7 kilometres in rain or rain showers, and the cloud will lower to 7 to 8 octaves of cumulus and altocumulus, with a base of 1,500 feet and a top of 17,000 feet. Isolated conditions of 3,500 metres visibility in heavy rain, rain showers, or rain and snow are forecast, and the cloud will lower to 3 to 6 octaves of stratus, with a base of 800 feet and a top of 1,500 feet, and 8 octaves of cumulus and altocumulus, with a base of 1,500 feet and a top of 17,000 feet. The last section of information at the bottom of each zone is a list of any specific warnings which are applicable to the zone area. These often cover aviation hazards such as cloud on hills, moderate or severe icing or turbulence, sub-zero layers, and mountain wave activity. The last line or two of text at the bottom of each AIRMET is a short outlook forecast for the next 6 hours. This forecast is deliberately kept short and concise, and unless any significant changes are anticipated, is simply given as little change. When interpreting AIRMETs, it is essential to appreciate that the information given in each zone is a simple forecast of the anticipated conditions at a given time. Sometimes specific mention is made of the timing of phenomena. For example, isolated patches of fog with a visibility of 300 metres are expected until 0900 Zulu. Normally, though, it is the responsibility of the pilot to interpret the information in its dynamic sense. Remember that the zone boundaries are normally described relative to a time, speed, and direction of movement. You will need to gain experience in interpreting how the weather conditions may change at any place in the forecast area by interpolating the forecast accurately. As mentioned at the start of this lesson, the format of AIRMETs does vary considerably from country to country. Therefore, When flying outside UK airspace, it is advisable to fully familiarise yourself with the AIRMET formats adopted by the Met Service of the other state. Understanding the format and language of the UK AIRMETs should provide you with sufficient knowledge to accurately interpret the different styles adopted elsewhere.